Hi everyone, in this video we're going to be discussing quadrilaterals and coordinate geometry review. In this first question we have quadrilateral ABCD with diagonals AC and BD is shown in the diagram below. Which information is not enough to prove ABCD is a parallelogram? So I'm going to circle the word not because that's going to be very important to us. We're looking for the one that does not prove it's a parallelogram. So remember, the key to prove a parallelogram is to prove that the same pair of opposite sides are both parallel and congruent. So let's look for the answer choice that has the same pair of sides are pair of opposite sides are both parallel and congruent. So that would be choice 1. AB is congruent to CD and AB is parallel to DC. That definitely proves that it is a parallelogram, so that one is out. Number 2, AB is congruent to CD and BC is congruent to DA. That means the pairs of opposite sides are both congruent. That also proves. So that one's out. And choice 4, AB is parallel to DC and BC is parallel to AD. That also proves a parallelogram because both pairs of opposite sides are parallel. So that leaves us with, it has to be choice 3. AB is congruent to CD and BC is parallel to AD. That's not enough information to prove it's a parallelogram because it could honestly also be an isosceles trapezoid. Let's look at the next question. In the diagram below of parallelogram FRED, Fred, shown below, ED is extended to A and AF is drawn such that AF is congruent to DF. Make sure you're always marking up your diagram. If measure of angle R is 124, also write that in. What is the measure of angle AFD? So AFD, I'm going to put in X. So let's identify where the parallelogram is. It's FRED. So this is the parallelogram. So if there's 124 here, there also has to be 124 here. Opposite angles of a parallelogram are congruent. Now notice this is an isosceles trapezoid, and this is a straight line. Angles on a straight line add up to 180 degrees, so I can do 180 minus 124. 180 minus 124 is 56. So if this is 56, then this also has to be 56 because the base angles of an isosceles triangle are congruent. So then, remember, angles in a triangle add up to 180, so I can do x plus 56 plus 56 is equal to 180. 56 plus 56 is 112. $180 minus 112 is 68. And that is our angle that we're looking for. Next, in the diagram of rhombus PQRS below, diagonals PR and QS intersect at point T. PR, which is the length of a diagonal, is 16, and QS, which is the other diagonal, is 30. Determine and state the perimeter of PQRS. Now remember, the diagonals bisect each other. So I want to cut this in half, so I'm going to divide it by 2, and I'm going to get 8. So PR gets sectioned off in 2 pieces of 8. The same for QS divided by 2. 30 divided by 2 is 15, which means this is 15 and this is 15. Again, I'm looking for the perimeter of PQRS, so I want to know what the side length is, and then I can just add it 4 times or multiply it by 4. Also remember that the diagonals of a rhombus create 90-degree angles. So I'm left with a right angle that has 2 legs of 15 and 8, and I want to know what the hypotenuse is, which is the longest side across from the 90-degree angle. So I have to use the Pythagorean theorem. 15 squared is 225 plus 8 squared, which is 64. 225 plus 64 is 289. Take the square root of both sides. So the square root of 289 is a perfect square. It's 17. So let me get rid of that squared. C is equal to 17. Now that's not the perimeter, right? That's only the length of one side. All these sides are 17. So I can add 17 plus 17 plus 17 plus 17, or I could do 4 times 17. 4 times 17 is 68. That's the perimeter of the rhombus. So remember, the diagonals bisect each other. So cut the diagonals and divide it by 2. And the diagonals are perpendicular. They form a 90-degree angle. So you're able to use Pythagorean theorem, a squared plus b squared equals c squared. That will give you the length of one side, but because I want the perimeter, I have to multiply it by 4 because there's 4 sides. Lastly, we have to discuss how to complete a coordinate proof. Remember, we used the distance formula 6 times to prove a parallelogram, a rhombus, a rectangle, and a square. We find the distance of all 4 sides plus the 2 diagonals. For a trapezoid, it's a little bit different. We use the slope formula 4 times to prove one pair of opposite sides are parallel and the other is not. And for an isosceles trapezoid, we still do the slope formula 4 times, but we also do the distance formula twice to prove that the non-parallel sides are congruent. And then don't forget, for triangles, we use the distance formula 3 times for isosceles, equilateral, and right. And to prove that something's a right triangle, we use the distance that we found for all 3 sides and we put them into the Pythagorean theorem. And if it satisfies the Pythagorean theorem, then it's a right triangle. And again, at the end of every coordinate geometry proof, we write a big conclusion statement proving why a parallelogram is a parallelogram using the definition.